Okay, so again, go to the appropriate tables, appropriate substance, appropriate set of units, and then determine the phase. And then once you, so this is really where you figure out which table and then which row within that table. Once you know the phase, then you can go to the right table and you can figure out exactly where you are on that table. That's the state. Once you know exactly where you are within that table, you know where you are on the PVT surface, and then you've really locked in the state. So once you know the state, that means you know all of the properties. And then what you want to do after that is just, you could record all the properties. And I'm not going to. I'm not going to record all of the properties unless I need all of the properties. I'm just going to record other properties as needed. What do I need to solve the problem? Right? In Chapter 3, they'll say, oh, determine the enthalpy change, determine the internal energy change. They'll tell you exactly which properties you need. Later on in Chapter 4 and Chapter 5 and throughout the rest of the course, they won't tell you which properties to record. You will have already set up a first law equation or a second law equation and all the other equations that you need to solve those equations. And then you'll know when you get to the property tables which ones you need. Do you need the U, the H, the S, the V, or all four of them, or just two of the three, or which ones do you need? Okay, so all right, so again, this is going to seem like a big, long set of steps, and then what you'll see on the next exam is this is just a little tiny piece within a bigger problem that you're going to have to solve, right? So you'll have to do it at least twice because you'll have at least two states for each problem. So anyway, we'll get there. Baby steps. Right now we're just learning how to go through this process. As we saw, and as you've seen in the homework, this is the hard part right here, determining the phase. And it's really not that hard once you get the hang of it. Determining the phase. How do we determine the phase of a substance? Well, let's expand that. Determining the phase. Again, I like to draw the picture of it. I think that's much more efficient than putting it in words, but we'll put it in words. You know what? We'll put it in words, okay? So determining the phase. If I've got, there's two main categories here. I could be given P or T and V, U, H, or S. Right? So one of these two and then one of these four. I need, again, at least two properties. Well, how does that come to me? Well, I could be given one of these two and one of these four. That's one possibility. So there's 8 different combinations there, right? Is that right? I'm terrible at statistics, but I think that's right. 8 different possible combinations there. And they all follow this same pattern. I could put P or T on the y-axis. I could draw arbitrarily a dome shape in there, and I could plot V, U, H, or S. And what I can do is I can, at the given pressure or temperature, I can go look up what is the value for saturated liquid and what is the value for saturated vapor. And that would be this point on the saturated liquid would be this point on the curve, saturated vapor would be this point on the curve. If you really want to get technical and go look up, you could go look up the critical point properties. That's the top of the dome. Put that on here. Okay. I'm probably not going to. This is more than enough information. Okay. And again, when you plot on this chart, then, and it doesn't have to be perfect. I don't have to have a perfect scale down here. I just need to know these 2 points, and then what is the third point? If I'm going to have V, U, H, or S, where does that fall relative along this line relative to these two values? If I'm back here, that's going to put me in the compressed liquid region. To the left of the dome, to the right of the dome puts me in the superheated vapor region. If I'm under the dome, I have a saturated mix. Okay? And then The other category, and again, I'm going to put all this in words down here. The other category is given P and T. So that's the other possibility. Steve, what if I'm given U and V? You're not going to be given U and V. I'm not going to give you U and V. If I do, you're also going to have P and T. Okay? I'm not going to give you just U and V alone. You don't have to worry about that with me. Okay? But just given P and T, you have this curve. Over here is liquid. Over here is superheated vapor. So at the given pressure, you go look up the saturated temperature, and you figure out, have you exceeded the boiling temperature? If you've exceeded the boiling temperature in the vapor region. If I've not exceeded the boiling temperature, I'm back here in the liquid region. So at the given pressure, go look up the boiling temperature, or the saturated temperature, and see if you exceeded that or not. That's really about all you have to do given P and T. It's a little more straightforward. Now, if I wanted to put this in words, okay, I like this. I don't know about you guys. If you don't like these, I know a lot of students are like, Steve, do we have to draw the diagram? You don't have to. You don't have to. If it doesn't help you, don't draw the diagram. Okay? If you can see it in your head, don't draw the diagram. That's okay. If you would prefer to see it in words, let's write it in words. This is 5 different if-then statements. Right? So let's write them all out. If at the given P or T. Okay? So that's kind of a blanket statement. At the given P or T, you have a V value, and I'm just going to write V, and that's just the same for U, H, or S. I'm just going to write V. If my V is less than the value for saturated liquid, right, you have compressed liquid. Okay? So if at the given P or T, I've got V equal to V sub F, well, that's the easy one. You have what we call saturated liquid. That is liquid right at the boiling point, right at the point of the liquid vapor phase change. If at the given P or T, you've got a V value between the saturated liquid value and the saturated vapor value, we call this a saturated mixture. If I have a saturated mixture, I need to find the quality. The quality we write as an X, we call it an X value. The quality is going to be between 0 and 1. We find the quality based on V minus V sub F over Vg minus V sub F. We go look up the saturated liquid and saturated vapor values. At the given pressure or temperature, look at these values up, find this difference, take the ratio. That gives me the amount in the vapor phase. If it's a mixture, part of it's in the vapor phase, part of it's in the liquid phase. This tells me how much is in the vapor phase, and I can find the same quantity with a U value, right? So UFG, H value, etc. Find it with an S value. I'm out of room, so I'm not going to write the S value also. Okay. Fourth option, like I said, it's like 5 if-then statements. If at the given pressure or temperature, the V is equal to the value for saturated vapor, that's pretty self-explanatory. You have a saturated vapor. Right? So if V is equal to V sub G, you have a saturated vapor. And then finally, if V is greater than V sub G, you have a superheated vapor. Again, you're welcome to write it all out in words, and probably it's good to write it out in words, and that forces your brain to process this and says, you really trick your brain into saying, hey, this is really important, you need to remember this, and this gives you another way to think about it. So it's good to write it out probably one time in words, and then after that, I personally find this more efficient. If you don't, if you find this more efficient, that's fine. It doesn't bother me at all. For the other scenario over here, given pressure and temperature, I tend to build a table. Right, so I build a 3x3 table. So let's say for compressed, I'm going to put in the middle here, compressed liquid. Okay? So again, I'm going to build a 3 by 3 table. So there's the first row, 3 columns wide, 3 rows deep. Okay, so it's a compressed liquid if at the given pressure, your temperature is less than the saturated temperature. Right? So again, at given pressure, you go look up the saturated temperature, and your temperature puts you back here. That's in the liquid region. Okay. Now it flips if you want to go the other way. I'm given the pressure, I go look up the boiling temperature. That's what I do. This is the way I think about it. My brain works. You can go the other direction. You could, at the given temperature, go look up. So at the given temperature, you go look up the saturated pressure. And if your pressure is greater than the saturated pressure, that puts you in here in the liquid region. If your pressure is less than the saturated pressure, that puts you down here in the vapor region. It kind of flips. So if at the given T you've got more pressure, a higher pressure than the saturated pressure, and the way I think about that, if I have more pressure, so the saturated pressure, that is the minimum pressure required to maintain liquid. If I have more pressure, that's more forces pushing the molecules together. They can't escape each other. They stay in the liquid form. That's how I think about it. Is at the given temperature, find the minimum pressure to maintain liquid. Do I have more than that? Then if that's the case, then I have liquid. But this is the way I normally think about it. Given pressure, go look up the saturated temperature. Am I above or below that? That's how I think about it. Now, this one's kind of weird. At the given pressure, if my temperature is equal to the saturated temperature, it's not necessarily weird. It's perfectly possible. Here's the problem with that, is it's saturated something. Right? Saturated something. This dome, when viewed along the PT axis, this dome becomes this curve. So if all I know is that I'm somewhere on this curve, I could be anywhere in between here. Does that make sense? Because when I view from this direction, all I see is this curve. I don't know if this dot is here, here, or here. It could be anywhere in between. I need a third property. This is not something I would give you on an exam, especially not intentionally. You would need a third property. Okay, now on a homework problem where you've got time to explain to me why you can't do this problem, okay, that's fine. If yeah, but that's still evil, and I try to not be that evil. Yeah, at the given pressure, if your temperature is equal to saturated temperature, you cannot find the other 4 properties. You need a third property to find one of the other 4. Okay. Now, if they told you it's saturated vapor, then okay, we'll go pull the vapor values and you're fine. Same thing over here. At temperature, if my pressure is equal to the saturated pressure, then it's just saturated something. We don't know what it is. The superheated vapor. So the superheated vapor occurs when at the given pressure I've got a temperature greater than the boiling temperature. It's boiled off, right? So at the given pressure, go look up the boiling temperature. Have you exceeded it? That puts you here in the vapor region. You can flip that and say, well, at the given temperature, do I have less pressure than what is required to maintain liquid? That's the saturated pressure, is the minimum pressure required to maintain liquid. If I have less than that, the molecules have been allowed to escape. Right? Graphically, if I go look up at the given temperature the saturated pressure, and my pressure is less than that, that puts me here in this area. That puts me below the dome region, so to speak. Okay. Again, I don't necessarily think about it this way, but I can if I have to. This is normally how I think about it. Okay. Again, my preference, diagrams. If words are good for you, words are good for you. That's fine. It makes me no difference. I'm just telling you how I think about it. That's not a bad stopping place. Let's take it. All right. Be back in a second.